Okay, so this is kind of a review of linear programming. It's the process of finding a feasible region. You guys know kind of how that looks now, right? If you had something like this and you shade it on this side and that side and this side and that side, you get this like shape. Where are the answers on that, puppy?
All the red, I mean, in like this.
Yes, the things in the red are the answers, but where are the answers to the answers?
Points.
The corners, yes, those spots. So today, if there's one thing I can help you with, it's trying to figure out where those cross, okay? So if you have two equations and they're like both, lines that are like this, kind of at a slant, not straight up and down, or not straight across, if they're kind of tilted, you'll be able to use the graphing calculator and just go second, calc, intersect. And you get really close with your little spider thing, and you get really close to here, and you go enter, 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 and it'll tell you the answer. Let's do one like that right now. Okay, so everybody put this into your calculator. We're going to put in, you're going to have to solve this, but that'll be good for you, is less than or equal to 30. And we're going to say y is less than or equal to x plus 5. Get those two equations in your calculator. Yeah, the first one has to get solved. Then, to figure out where they cross, we'll just do second calculate intersect. It'll be easy. I'm going to pause while you try that. Okay, so I hope you figured out that it was negative x plus 30. Raise your hand if you had that part right. Okay. That was us solving this for y. So we subtracted x from both sides. You get negative x plus 30, enter. And the other one is x plus 5. But there's something wrong with the way I did it. Yes, sir?
You have to change the shade.
Yeah, I've got it shading where? What way right now?
Down because it's less than.
Yeah, wait, what's mine doing right this second, though? It's shading what way?
Greater than.
Mine's shading like a greater than. Very good. So I got to hit enter here. And I want to shade less than because my sign says less than. Less than is below. So I got to go down here and I got to change it to that. And then I say, okay. I'm shading below it. And I got to do the same thing on this one. And I'm going to go enter to get in there. And then move down and change it to shade below. Okay. Yours is actually probably simpler if it's an older calculator. Just hit enter a bunch of times until it turns into a down shaded triangle. All right. Now I'm going to hit graph. Now you may recall I had Windows settings that were going out to 3000 last time. So you get how that'd be a problem? I can barely see that one graph. It's a tiny titch of blue in the lower left-hand corner. So I'm going to change my window, and I'm going to just go out to like 20 and negative 20 or something. And let's see if that works better. You got to be smart about your window, otherwise you won't be able to see your graph well. Oopie. Thank you. Sorry. I'm going to go back to my window. And I did my x max is negative 20 instead of regular 20. And let's try that. Okay, that's better. Accepted shading everything. Oh, there it is. Okay. Maybe I should have gone out further. Dang it. My rule is go big or go home, and I should have gone bigger. All right. So I can see most of the things that I need. Do you get that you can't have negative time and you can't have negative a lot of things, and therefore I'm not going to want to go, come on computer, right on the board. Yeah, good computer. Okay. So, and I also therefore want to shade this direction. And I also want to shade above this line because you can't have negative TVs or whatever. So I'm going to shade above that. Final answer is this would be your feasible region. Do you get what I'm talking about? It like narrows it down a little bit more. You want to know what my equations are? shade underneath. It's the shade underneath, the triangle shaded downwards. Okay, so did yours turn out to be a triangle like that? Okay, good. Then here's the important spots. This one's easy to find because you're going to use second calculate intersect. This one isn't actually anything intersecting. It's just a spot. But I'll give you a clue how to solve that kind. You can't do it because you can't enter x equals 0 on your calculator. I'm going to pause for a second. Okay. So listen up. Thank you. All right. So now, this one, I want you to find second calculate. Some people are still talking. That's not polite. Listen, please. All right. Focus. Not on that. All right. This one right here. You're going to be finding where these lines cross right there using second calculate intersect. If you don't know how to do it, we'll find that out soon. Okay? Because you're going to show the person next to you. If you don't know how, then ask the person next to you how to do it. If neither of you know how, raise your hand and ask me, and I will show you. Finding where those two lines cross right there. Have it on your screen, and it'll say intersect, and it'll say where they intersect, if you know how to do this. Okay, quick reminder how to do it. Second, calculate.
Wait, you did this?
Intersect. Enter. Then you just move the little spider thingy until, first of all, you have to be able to see it. There it is. And I'm going to move it. You know, it's just a good practice in case you do have multiple lines. It'll be more likely you'll get the right answer. So, no, you don't have to do it. As long as it says intersect and it brings the little blinky spider to where you wanted, you can just hit enter, enter, enter. Did you get 12.5, 17.5?
Yes.
All right, good. Now, that's one of the intersection points. That's one of the possible answers. So if they were asking, what's the most profit he could have? You'd take those numbers and stick it into the what? Optimization equation. Good. Okay. Now, here's a tougher question. This spot right there, do you get, it's where it crosses the y-axis. It's where it crosses the y-axis. Okay, so which equation is that? Which of the two equations is that? Is it A or is it B? I can tell because which one's slope is positive. See, this one's got a positive slope, right? It's B. B has the positive slope, so therefore that's B. And it's this guy right here is crossing the y-axis, which means that what? If it's a y-axis, it's where what? X equals 0. See how if x equals 0, you can solve that? It's more powerful than a calculator. It's your brain. Your brain is more powerful than this calculator. Granted, this calculator can do faster multiplication, but you have such incredible brain horsepower up in your brain. The brain is still better than any computer. Right now, we can still say that. They may make a computer someday that can outperform the brain in every area. Right now, it can outperform the brain in a lot of areas, but still, you know, complex thought is still something a computer can't master, thankfully. Otherwise, our computer overlords will be taking over soon. Okay, so if this is the y-axis, which is where x equals 0, do you get, I just need to put an x equals 0 right there. And now what's my equation say now? Y is less than or equal to 5. So therefore 5, you can always change these to equal to make your life simpler. Y must be 5. Therefore, what's that point? Right there. 0, 5. This point we figured out already is 12.5, 17.5. And lastly, I'm going to ask you to figure, well, that point would be really easy. It would be the origin. What is it? 0, 0. And then over here somewhere, this line would touch, and let me blow that up a little bit. It would look like this. There was a line going down like that, and it was going to hit right here. It was on the edge of our feasible region. And our feasible region looked like this. Here was the four corners of it. And I know yours can't do this, but we can, in our brain, know that we can't shade this way and we can't shade that way because those would be like negative turnips and negative time, things that can't happen. Okay, so then this spot is where it hits the x-axis. The x-axis is where what? Y equals 0. And therefore, if I know this equation, can anybody tell me which one it was? Y equals what? Negative x plus 30. That was that equation. And I stick in what again at this spot? Yes, stick in 0 for y. So you stick a 0 in there. And now I have 0 equals negative x plus 30. Solve.
30.
Yep. Subtract 30 from both sides. Negative 30 equals negative x. So x equals 30. Is that a point? Yes, it is. It's the point what comma what?
30 comma 0.
30 comma 0. Good. That's the part people have the most trouble with is, okay, Mr. Server, I got this graph, and the graph looks like this, and I can't figure out, well, they can figure out where these two lines cross. They just do second calculate intersect. But they can't figure out where that spot is or where that spot is, if this was my feasible region. Now, I'm going to give you the equations for this situation. I want you to tell me what this spot is, what that spot is, and what that spot is. Okay, so here's your two equations. This one is y equals, I'll make it red. That line is y equals negative 2x plus 20. And this line, I'll make it black. The equation for that line is y equals negative 5x plus 30. Use your calculator. Notice I didn't even say less than. You know why? I already told you the feasible region's in here. So all you need to do to see where things intersect is know where they're equal. If you want, which sign should I have if I'm shading underneath them? Yeah, I could say less thans. If you want to do the shading, go ahead. But you don't really need that. If all you need is where they intersect, it doesn't matter if you shade or not. I want all three. This spot, and this spot. You're going to put them here, here, and there. Try to find those three intersection points. I'll pause for a second while you give that a try. Okay, some help on that. First of all, see the easy one, the one that calculator can do. I'm going to do second calculate intersect. So I got to move this a little bit. Second, come on computer, calculate it. There we go. Intersect is number 5. And then it is true, if I only have graphed two things, I can just hit enter, enter, enter. And it does save you time. You get that that's a not nice number, but did you get 3.3 repeating, also known as 3 1/3, comma 13 1/3? Raise your hand if you got the same thing as I did. Okay, good. That's one of the dots you'd have to then check in your optimization equation. There's only 3 spots that it could be, you know, if we're finding maximums. If we were finding minimums, I would already know the answer. Do you get how that would always cause the minimum? 0, 0. If you stick 0 into your equation, you're always going to get the smallest answer possible, as long as you can't use negatives. Okay, so anyway, how about this spot right here? Who thinks they know what that spot right there is? Raise your hand if you think you've got that one. Okay. Mr. FD, what do you think it is? Yep. So what comma what?
It is, I got 5.96.
Okay, except, yes, I think that's right. Okay, so 5.96 5.96, I'm going to just call that 5.9, even though it probably rounds to 6, comma, 0. Raise your hand if you got the same thing for that point. Uh-oh, that's crickets. Okay. It seemed plausible. How about if I'm going to double check you by doing this? It's this equation. Do you get that that equation has to go with the x-axis? Which is, if the x-axis is where what? Y equals 0. If I'm going to put in a 0 right there, I'm going to have 0 equals negative 5x plus 30. So I'm going to subtract 30 from both sides. I get negative 30 equals negative 5x. Divide by negative 5, x equals 6. That's pretty much 6. I think he had it right. Oh, you just, the 5.9 thing bothers you? Versus the 6? Who had 6 in here? Raise your hand if you had, okay, for Pete's sakes. And then it's just a matter of rounding. And believe it or not, 5.96 and 6 are so close that graphs seems like, oh, it's on a calculator, it's got to be perfect. The calculator actually reads its own graph on the screen. And if you have yours zoomed out far enough, it sometimes can't be super accurate. So actually, it'll be off a smidge on its own graph. Of course, I would have given you credit for that because it was close enough. All right, so most of you guys knew it was 5.9. You just rounded it to 6. Okay, good. How about this other spot? This other spot over here. The other spot is where y is, oh no, it's the y-intercept. And so that's the y-intercept intersecting with this. The y-intercept is where x equals 0. You put in a 0 right here, and you end up with y equals, again, I don't care about the signs right now, I just need a number, technically less than, but 20. So therefore, that spot must be x is 0, y is 20. Raise your hand if you had that one right. Okay, cool. Then one of those spots would have given you your maximum. All right, that's the hardest part, and now you've learned everything you need to know to be able to take the test, but the test is until Tuesday. All right, so let's start another homework problem with you. So everybody find today's lesson 4's homework. I'll pause while we do that. Okay, so here it is. It's the lesson 4 linear programming worksheet D. Stay focused, guys. All right. Will has been sent to the grocery store to purchase bagels and muffins. This is a good problem. It's a safe one. I've done it before, and it works out nice. Then we have a one about an electronics company manufacturing MP3s and DVDs. These are your 2 problems that I need you to do. I do not need you to do the Minnetonka Superfan scarves. Okay, so we're just doing 1 and 2 today. All right, just doing 1 and 2. Okay, so your first thing is you got to write equations, and your very, very first thing that they've always done for you before, but they didn't this time, is to tell you which one's x and which one's y. Now let's do the same as each other so that when we grade this, yours won't be all backwards. So has somebody already determined that they're going to make bagels this and muffins that? All right. Here's the way that we should do it then so that it works for next time too. The first thing they mention, we're going to make, what do you think? X. You got it. So what are the first thing they mention? Bagels. So bagel's going to be X, muffin's going to be Y. Sorry about that. All right. And he can spend at most $28. Here's a common mistake answer. X plus Y is less than or equal. That's even pretty close to right, but it's wrong. Because X is how many bagels you have, and Y is how many bagels you have. How can how many bagels plus how many bagels make a dollar amount? It can't. So that's a wrong answer that people put a lot of times. How can I make it so it is a dollar amount? Yes, sir?
2x plus 6.
There you go. That is a right equation. A package of bagels costs $2 and a package of muffins costs $6. Okay, cool. He needs to buy at least 2 packages of bagels. 2x? Is that what I'm supposed to do? No. I got to have an equation in there. I got to have like x is it just x equals 2? Does that mean, did I see the right thing there? No? What, less than, greater than? Greater than or equal to, less than or equal to? Greater than or less than? He's made a new symbol, folks. It's the greater than or less than. Nope. You got the actual answer? Greater than or equal to. Very good. X is greater than or equal to 2. And then muffins is the Y. And what's that? Greater than or equal to 3. Good. All you got to do now is graph all these things. And I can make a rough sketch of it. I'll tell you generally what it looks like. X is bigger than 2. Here's the line where X equals 2, and it's going to be bigger than that. And here's the line Y has to be greater than 3. Here's the line for Y is greater than 3. It's kind of like that. And the last one is, there's always a slanted line, and this is the one. And it's going to be, I don't know exactly where, but something like that. And it's less than 28, so it's like this. And get how we got a triangle? You get that we now need to find the corners, and that's exactly what we just practiced. Okay, this spot here, it's not on the y-axis, but what was this line that was running like this? This line I keep drawing over and over and again. What is that line? Y equals what? Come on. Come on, it's on the board. Y equals 3, okay? Y equals 3. This right here is this line right here, and it's where Y equals 3 hits this line. What's that line?
2. X equals 2.
X equals 2. So what's that point? 2 comma 3. Okay. This point here, that's where the line X equals 2 hits the line 2x plus 6y is less than or equal to 28. Again, you could use a calculator if you could tell it x equals 2, but we don't have an x equals screen. I really wish we did. We only have a y equals screen. Okay, so therefore, you got to use your brain. More powerful than any calculator. X equals 2 just means you stick a 2 right there, and you solve. And then you'll know where they crossed. I can tell you the x of where they crossed. It's 2 comma, I don't know what, but you figure it out. You're sticking a 2 in right there and solving. Okay, and then this last spot right here, that's the spot where y equals 3 hits 2x plus 6y is less than or equal to 28. And that little system of equations, it's called, can be put the one in the other. Y equals 3 goes in here, and then you solve it, and you'll know what the other part is. So this is, I already know the y of it. It's y equals 3. I just don't know the x of it, and you'll figure it out and put it there. Then, what's the optimization function? What's the thing we've never used yet? You know what? They never even really say what they want maximized. But you tell me, if you're buying these packages of muffins and you've got 28 bucks, do you get the goal is probably to buy the most stuff? Does that make sense? Okay. But they have some rules for you. Like you have to get at least 2 packages of bagels. You know what I mean? Otherwise, you'd want, to just buy all muffins or all bagels. Keep it simple. But they told you got to be at least 2 packages of bagels. So which of these spots gives you the most stuff? That's what you're deciding. Hint, the things that are close to the origin give you the least stuff because they're close to 0, right? So 2 comma 3 is one of your options. It's in the feasible region, but it's not your maximum. Okay? So it's either this one or that one that's going to give you the most stuff. All right. In fact, this question never even asks which one, it never even asks the question, which of these spots gives you the most food. It never even says that. All it says is graph it, which I did, and find the vertices. which I helped you start. And that's all you'd really have to do is graph it and find the corners, because that's what the question said. All right, so I've done halfway done number 1 for you. You do number 2. If you've been falling behind on this right now, you could be hiding in the weeds. I wouldn't even know if you're really lost right now. But you'd know that. And you have a test Tuesday. And the only day you can come get help from me between now and then is Monday. So if you've really been lost lately and you're not getting how to do these, try these 2. Check the answers. Make sure you're doing it right. If you tried it and you checked it with the answer key and you're still not getting it, feel free to come in the morning, Monday morning. I'll try to give you some extra help. All right, that's all I've got for you for today.